Hello and welcome to another tutorial. We are going to continue our discussion on the ideas or the concept of object-oriented programming, and now we're going to focus on the Java side of the object-oriented programming, which basically tells us how to create classes and how to create instances of those classes, which we call them objects, and other topics that are mainly focused on the syntax in the Java, right? Now, the ideas that we discussed previously, which was about the general idea of what is an object, what is a class, what is an interface, why we prefer to abstract away the behavior of the classes using interfaces. Interfaces don't hold an state because they are mainly purely abstract constructs by default, and these ideas are something that are applied to any object-oriented programming in any language: Python, C, C++, Java, right? Obviously the syntax is different in different languages, but Java was really the one that popularized the idea of abstraction through interfaces and concrete classes, and then how we put them together to create an application. All right, so now we want to focus more on the syntax, which is related specifically to Java. So this part of the tutorial covers the basics of class definition, object creation, nesting classes, enumerations, declaring member variables. Note that we said that usually the terminology of member variable is used in C++. In Java, instead of member variables, we prefer to say fields, right? And the reason was that, again, in C++ there is a global scope that doesn't belong to any class, right? And in the global scope, you can have variables. So they are sometimes called global variables, or people just simply call them variables. So in C++, when we say a variable, it means it's a variable defined in the global scope. It doesn't belong to any scope. But then C++ allows types like classes to have their own scope, and they decided to call those variables in the class scope member variable. But in Java, we don't have a global scope, right? Everything has to belong to a class. So the idea of using member variables is really moot. It's not that useful because all variables are member variables. So we just call them fields, methods or member functions, and constructors, which is a special case of methods we use to actually build an instance or an object of a particular type class. And again, sometimes I interchangeably use the keyword type with a class, but we saw that in the previous lectures that the idea of type is much more general than the idea of class, right? When we say class, it's mainly the definition of the class type in the source code, right? But we saw that there are some complications in the bytecode. If you have package declaration, the name of the type, I think we wrote this actually for this object class path. We said that the name of the type in bytecode is actually the fully qualified name. If you declare a package, or if you say that my class belongs to a package in the source code, right? If you don't have this line, then the name that is written in the bytecode for your type is a class path again. And we said that type is a more general idea. I think we wrote it somewhere in the car class, I believe. Let's see where we wrote it. Let's see, was it in the cat, in the animal? Let's see, was it here? So I'm pretty sure we wrote it somewhere that the type is more general in the sense that yeah, so the type is more general, that applies to anything in Java, any type. A type means it could be a class, interface, enum, etc., right? And the type is what the JVM looks for, and any class or any type in the source code, when you declare it, and then it gets compiled to a separate class file. So even interfaces are compiled to a dot class, right? Everything is compiled to a dot class file, but then the name of the type in dot class file doesn't have to be necessarily the name of the file, and it depends on, again, the fully qualified name. Just be very careful about that, right? We will see more examples. And when we say, usually in the object-oriented programming, people talk about the super class. But in Java, we said that the best terminology is saying super type, and type could be a class, an interface, enum, anything, right? So again, the type is a more generalized concept than a class. So creating classes, syntax to create and initialize primitive type variables, defining methods, adding methods to a class definition. Methods are behaviors. Providing constructors for your class, providing constructors so that you can actually create instances of the object. And when you call a constructor, you use the new operator, and then you pass some parameters to automatically also initialize your class. Calling methods and constructors. How to pass information. Information means arguments. When you type your source code and you're trying to use an object and call a method on it, to a method or a constructor. Creating and using objects. How to create and use objects efficiently. More on classes. Understanding the dot operator. The this keyword. And then the access control, access modifiers. I've already talked a little bit about those: public, private, protected, etc. Nested classes. A class can be in the definition of a class can be inside another class. We will see what happens in that case. Usually Java compiler treats them differently based on whether the nested class is a static class or a non-static class. So again, we saw that the fields or member variables or even methods or behaviors, anything that is defined in the scope of a class, can be either qualified as a static thing or a non-static thing. Same with nested classes. If you put the class definition inside another class scope, you can declare that inner class, the definition, as a static or non-static, right? Because again, it follows the general rule that anything inside a class, anything inside the scope of a class can be qualified as a static or non-static. When to use nested classes, local classes, anonymous classes, and Lambda expressions. So Lambda expressions are a little bit more advanced topic, but we will also briefly discuss item 8. So there are nested classes, local classes. If you put the definition of a method put the definition of a class inside the method, the scope of a method. Again, in order to create a class, you have to first declare its definition and provide a scope and put some fields and methods, right? That's the meaning of a class definition. But then the question is, where can we put this? And we can put this, in fact, in Java, it allows you to put it in any scope. So obviously one scope or one place is to put it inside its own source file. So which means the class itself creates a scope. But you don't have to do this. You can put this class definition inside the scope of a method, and it's called a method local class or a local class, right? Or you can put it in the scope of another class. It's called a nested class. Or you can put it inside the scope of any class or any method, but don't give it a name. It's called an anonymous class. It's a class definition that doesn't have a name. Lambda expressions are a special case where these are basically binding to an interface type. So these are you can think of it at the moment for abbreviation for the implementation of an interface type, right? All right, let's start with creating classes. So the topics is declaring classes, declaring member variables or fields, controlling who has access to the member. This is the concept of access modifiers, setting the type of the variable. Again, we've seen that in the past. Any variable, whether it's a field of a class or a local variable, has to be a type, has to have a type. That's just because Java is an object-oriented programming. And we said that the fields don't have to be all primitives. They could be object references to other types, and that's the concept of composition. An object can have data that are actually instances of other classes. So that's how we build very complicated types or classes based on the smaller or simpler types, right? Because the idea is that whenever you develop a very complicated application, you want to start with very small classes. They hold like 2-3 primitives and some very simple methods, right? And then you test them and fully test them. So you make sure that you test all the small classes and they work fine. And then they compose them or put them together to build a larger class, right? So that's a very interesting thing. For example, in this bicycle class, you can have a smaller class that is called brake. And brake, for example, has has the parameters or hold the data for gear and cadence, something like that. And then instead of defining these two primitive fields inside the bicycle, you define an object reference, public brake, bicycle brake, or something like that, right? So you create a new type brake, a new class definition, and it has a smaller number of primitives, right? So sometimes it's the better way. Usually because object creation usually is a little bit expensive, or it's not as cheap as primitives, then it has a little bit overhead to your runtime, right, to efficiency of your code. But then it's always the best practice to use composition, build bigger, more complicated objects from smaller ones, because testing is easy. If you have already tested your small objects classes, you know that they work fine, there is no bug in them, then you are guaranteed that when you put them together, at least those small pieces are the logic is correct, and then you focus on the logic only of the new class, the bigger class. And setting the type of variable and naming a variable. And again, we saw in the previous lectures what are the basic rules for naming variables when you do programming in Java, right? Those are syntactic rules. So declaring classes. The introduction to OOP, or object-oriented programming concepts, in the section titled Objects, Classes, and Interfaces used a bicycle class as an example, with racing bikes, mountain bikes, and tandem bikes as subclasses. So this bicycle is a superclass or supertype or parent, and then we can inherit from it. And again, we inherit, or we go the inheritance route whenever the is a relationship makes sense. So a mountain bike is a bicycle, right? A mountain bicycle is a bicycle, so it makes sense to go the inheritance route. Here is sample code for a possible implementation of a bicycle class to give you an overview of a class declaration. Subsequent sections will back up and explain class declarations step by step. For the moment, don't concern yourself with the details. So again, we declare a class, and usually we put it in a in a source code. So let's create a new package, and we saw that the concept of package means we're just grouping related classes together, right? So I'm just going to say that classes. So this, all right, and then I'm going to create a new class, and we call this bicycle. Actually bicycle, and finish. So Eclipse creates a source file and then adds the package declaration. And so far we've already seen what this means. This means that when this source code gets compiled and we get a unique or separate class file which has the name bicycle.class, right? So we get a bicycle.class after compilation, but the name of the type in the bytecode is not bicycle. It's basically a package declaration dot bicycle, right? Again, this is just to refresh your memory, because this is a very important concept that we always come back to it and review it. So if I go back to my source code, classes, bicycle, open it with class file decompiler, and zoom in, public class, this is the packages dot the name of the class. So this is the name of the type in the bytecode. Just again, I always emphasize this because there's a little bit of difference between the name of your class file, which is obviously the name of the public class. There can only be one public class in your source code. But then the name of the type, that's what the JVM looks for when you try to create an instance of this class, is actually the fully qualified name. So then the idea is that when you run your Java application from the command line, you have to set the class path correctly so that this folder hierarchy is satisfied, right? So there's a bit of intricacies, and we looked into these intricacies in the previous lecture. So if you want to refresh memory, definitely go back and watch those lectures. So we copy this source as the code here, bicycle, and again you have a type which is called bicycle. It's of type class, and we see other keywords like interface, right? They also define types, and in the future we see other keywords like enum. It also defines the top in type, and there are recent versions of Java we have other keywords like records. So I'm going to write this here just to have it types. So keywords that define type in Java. So obviously so far we've seen class keyword, and we've seen the interface keyword, right? A type, when you declare a type or define a type, you give it a scope, because all of these types get compiled to a class file, right? Which means they have a class or a scope, they have a scope associated with them. We will see enum, and recently we have the record, right? And yeah, so I believe these are the 4 keywords that actually define a type. So I'm going to copy and paste, or maybe also let's put this comment, multi-line comment outside, and I'm going to use Eclipse auto formatter to format the code. All right, so this bicycle has 3 primitive data, the 3 fields, right? This is the comment. The bicycle class has 3 fields, and again, field means member variable. These are the ones that hold the state or define the state of the class. And if they're static fields, so if you say a static int, right, any field or anything, field or method that is inside the scope of a class can be a static, non-static. So if it's a static, you see Eclipse has this nice feature that it italicizes the name, which gives you a quick indication that this is static. So if I go down and look at the name of a field which is not italicized, it tells me immediately that it's not static. But if it's italicized, it's static. Now Eclipse has much more features for your color coding your code. I highly recommend you to try to take the best advantage of these kind of features that Eclipse provides, because that makes life much easier for you when you look at the source code. Or because if something is italicized and it's blue, all the fields that are associated with the class are blue. Local variables are like brown. So it immediately tells me that, okay, this is a local variable, this is a field. If it's italicized, it automatically tells me that it's a static field. So I've done a little bit more customization. For example, if I go back and look at these interfaces, you see I've color coded, changed the default editor color coding so that interface types are kind of bluish color, but the classes are still black, right? So if you look at this declaration, this class is this type is a class, it's black. Animal, it immediately tells me it's a black because it's color black, it means it's a class. But then mammal and feline, because I've set the interface coloring to blue, it immediately tells me that these are interface types. Again, types. Eclipse editor allows you to have different colors for different types, because Eclipse knows what Java types are. It's either a record, enum, class, or interface. And down the road here, for example, if I try to say mammal.super.eat, for example, right? If I save this, basically what happens here is that let's see. So it immediately tells me that this mammal is an interface, for example, right? So yeah, if I go back here again, this one is also an interface. All right, so take advantage of this kind of color coding and this kind of customization that Eclipse editor provides, or I believe all IDEs provide some customization so that you can get a better or much easier way of understanding what's going on in the code, right? So I'm going to remove this static, and then we have one constructor. Constructor is like a special method. The name of the method is exactly the name of your class, and you pass some parameters in, and whenever you create a new instance of this class using the new operator, you just call this method. So you can always consider the constructor as a special method. And indeed, when we look at the bytecode, we will see that in the bytecode the constructor is like a method, but it has a special name which is called init. So init is a special method. Whenever it's called, the Java JVM calls actually knows that it means you have to call the constructor, and based on the parameter types, because the types of the parameters that are passed to the method is also written in the bytecode, because Java allows method overloading. So methods with the same name with different parameters, it's allowed in Java. So whenever you have the init in the bytecode and the type of parameters, the JVM knows which constructor to call. And the job of constructor is just to you pass parameters that you want to initialize the state of the object with, right? So just briefly saying that the job of constructor as a special method is to immediately initialize the basically the state of the newly created object, right? with the arguments that are passed to the constructor. Arguments that are passed to the constructor. That's it. That's the only meaning of constructor. Is a special method that you call when you want to create an instance. And then obviously you don't want to create an instance and separately initialize the state in these variables, right? Because right now these are not initialized. I mean, we've seen in the past that what happens actually, these state variables get initialized to the default value, because Java doesn't allow undefined variables or garbage variables for the fields or the state of the class when it creates an object. So they get initialized to 0 when the class file is loaded in the memory, right? This file is loaded. But if you want to create and immediately initialize the state of your class at one shot, then you can call the constructor, pass some parameters, and they initialize the state, right? And then we have methods. And then methods are just we've seen the concept of setters and getters, right? But we can also have other methods. That methods typically mutate the state of the object, right? They are called mutators. All right, going back here, a class declaration of a mountain bike class that is a subclass of bicycle. So we have this mountain class. We saw that we use the keyword extends to create a object or class hierarchy, right? And then this has a construct. So let's create also another class called mountain bike. So class name mountain bike. I'm going to, in Eclipse, you can immediately say that this class extends another class. So I'm going to say bicycle here. So this is a nice GUI. You don't have to do it. You can write the extends bicycle in your source code, but Eclipse provides this nice interface that you can. So now it extends this. So implicit super. So now it says that the constructor of the bicycle has to be called. So let's copy and paste the code here. All right, and you see this call to the super, and we will see what this meaning is. We saw that the meaning of super in the context of accessing the fields or methods. If you recall, when we were looking at where did we look at the super? I think it was somewhere, yeah, here. So we said that super keyword is reserved for accessing the stuff inside the super class. But if it was interface, we couldn't use super, so we have to use the name interface, name of the interface dot super. Then this means actually we're talking about the super type, which is this interface. If you just say super dot something, it means the super class. It only applies to the class type, right? But if you can implement multiple interfaces, then super doesn't point to any of those. So you have to explicitly use the name of the interface dot super. All right. Okay, so mountain bike inherits all the fields and methods of bicycle and adds the field seat height and a method to set it. Mountain bikes have seats that can be moved up and down as the terrain demands. You have seen class definition in the following way. So you say class keyword, and obviously you can have a access modifier, and each source file has to have maximum one public class. So if I say that this is not public, nothing changes. I don't get a compilation error. Mountain bike extends this bicycle, and it has access to the class definition because it's in the same package. So when you say that this class is not public, it means you have only other source files in other source files that are in the same package. They can access and use this type, this bicycle type. If I say that it's public, then it means anyone else in any package can access this. So there is no access restriction. So public really means that there is no restriction on accessing this type and creating instances of this type. So this is a class declaration, the class body. So we say that class and the name of the class, the name of the type, and then the scope. Each class defines its own scope. The class body, it just means the scope. The area between these curly brackets contains all the code that provides for the life cycle of the objects created from the class, right? So you create objects or instances of the class. constructors for initializing new objects. When we say initialize object, it means initialize the state of the object, right? And you don't have to initialize all the fields or member variables. Sometimes you just care about a few of them at the beginning. So constructor just means immediately as you create this object, initialize these variables that we pass as arguments to the constructor. Declaration for the fields that provide the state of the class and its object, right? So a state means the fields, and the convention and basically the best practice is to declare all the fields at the top. So the best practice is the fields, declare all the fields first, and then methods come after all the fields are declared. So that's the best practice. And usually if you look at this outline, you can immediately see which names here are fields, right? They're always at the top, and then which names are methods, and the green here means these are public. Now Eclipse has some nice features. For example, you can filter them, you can hide static ones, you can filter the fields if you just want to quickly look at the methods, right? You can only look at the public methods, because if a method is private, it means it's not part of the public API. So if you're looking at some person's library, other libraries, and you look at the code of their classes, you basically only care about the public ones if you want to learn about a library that some other person has written, because private ones you don't really have to concern yourself with them because you're not allowed to access them. So these filtering features are very nice. You can sort them. You can basically hide the fields, only look at the methods. You can hide the static fields and methods, only look at the non-static fields. You can only look at the public fields, or what is this one? Hide the local types, right? So you can also hide the local types. It's very nice feature, this outline. It can immediately tells you what fields and method this type has, this class has, and it also tells you whether this is a class, it's an interface, or something else. So a green circle with a name C means this is a class, because there's a C here. If it's interface, it's an I, which means interface. If it's an enum, it's an E, for example, which means it's an enum type. And then green color in Eclipse means it's a public type, so it means that the access modifier is public. So just by looking at the outline, you can gain a lot of information. Obviously it also shows the package declaration, so this type belongs to this package, right? So get used to looking at this outline and always have it open. I prefer to put it on the right side on my editor, and it's very helpful when I jump from one type, one class, one source file to another. It's immediate tells me. It also shows you the imports that a class has. For example, this type is a class, it's a public class, and it has this little triangle, which means it has a main method. This class is runnable. I can run my application with this main method of this class. And obviously you see that there's a main, there is a S here, which means this is a static method, just like any main that has to be static, and it has to be public. And for the methods, is also shows you the type of the parameters and also the return type of method. Obviously main has to return void. So this gives you a very complete information about the method, the access, whether it's a static or not, the return type, the name of the method, and what type of parameters it takes, right? It's a very complete definition. So definitely get used to this outline. So it was this was a introduction to going into more details of classes, constructing them. We will continue the discussion in the next lecture, so please stay tuned, and I'll see you in the next one.